Hello and welcome to this episode of T-Tech. On today's episode, we're talking about hacking network firewalls, attack and defense. So, we're starting here with, I'm going to talk about where this would be in the network and the different vectors it can be attacked by. And after that, I'm going to talk about the program I wrote to demonstrate this, as well as some defenses for this attack as well. So in this case, I have a typical enterprise network. We have a wireless LAN controller, a server on a DMZ, a guest segment, a staff, and some APs, and some smartphones and things connected to them. Then of course it has a WAN. It could be a dual WAN. It doesn't really matter. The main focus of this attack is going to be the central network firewall. And remember, this is just a logical diagram of this, so this could be a pair of HA firewalls or anything like that. It doesn't really matter for this. What matters is how we're getting access to the machine and installing the software. So where does this attack take place? Well, there's a few different places. Essentially, anywhere inside of the LAN that the attacker can get on the network and access the firewall from could be a potential vector. From here, the attacker's on the DMZ, so he's plugged right in there. In this case, he's just on the Wi-Fi, and again, remember, enterprise level APs have the ability to have different VLANs assigned to different SSIDs. So this could be an office SSID or a guest SSID. The main factor is limiting access from those networks to the firewall's management interface. That is the main thing. Even if it's just SSH, like on an OpenBSD box, you'll want to limit things like that. But again, you can move around in any of these segments, even over the WAN, depending upon what is vulnerable and what is being attacked. Now, in this case, I'm going old school, and we're talking about basically physical access to the machine or access over the cloud interface of the machine if it's on AWS or anything like that. We're getting access from there and then getting root privileges. You can also exploit this, potentially anyway, if a server program is running as root and it's like a web server listening on 80 or 443. That can be compromised, like you can then insert your own instructions in the program, like doing a buffer overflow. And when you do that, you could then ask to open a shell, and that shell would then be root. That's an example of a remote exploitable vulnerability. That's not what we're really talking about here. I want to drive home the point of securing logical access to the firewall and physical access. That's the point we're driving home with this video today. So we have all that done. We know that the attacker can be in several locations, over the WAN or any of those other three networks. So our process is going to be pretty simple. We're going to get access. That can be over the network. That could be physical access. That could be lots of different ways. Social engineering attack even could still facilitate those things. Then we're going to install a program. We could use the WAN to do that if we get access to a root shell on the firewall, which is what I'm going to show here. We're already going to pre-install the program, but you can grab it over a remote server. I'll show that process. And you want to execute it. After it executes, we want to maintain root access on the machine. This can also translate to a server as well, but it's essentially a remote access tool. It is going to maintain that access for us. Then, as a feature of like what a rootkit might have, we're going to hide our presence. And then, of course, we're also going to delete our remains. So from there, we'll have less of a footprint on the system. Normally as well, though, when you do delete a file, all that happens is the file system says that that part of the system can be overwritten by new files. So even like after this attack took place, you can use tools like Autopsy and take an image of the compromised machine and see traces of this, even if they're deleted. We're only trying to kind of hide from, the administrator that logs in a little bit, every week or every month or something. Something like that. They may not be fully familiar with all the OS level inner workings of whatever system, whether it's Linux or BSD, that actually underpins these firewalls. But that's what we're going to take advantage of and exploit. And again, I'm just trying to show you the importance of limiting admin access. That's your main thing. If you limit admin access to any network device, computer, or server on your network, you can then limit what can be installed on that system. That's what it comes down to, why this is working. In this case, I'm not exploiting anything remote, anything in a web server process. You totally could, and then get root on a shell and execute the program I made. But we're not doing that in this. We're just going to get full shell access and then go from there. So I will see you in the next section. I'm going to show you the program. And then after that, we're going to do a live demo. Alright, so this is the program I wrote to actually exploit a network firewall. Now, it applies to any firewall that uses a web GUI or a web application. This can be IPFire, this could be pfSense, this could be Palo Alto firewalls as they use a web interface. Pretty much any firewall software you can think of, appliance or otherwise, that uses a web interface can be exploited from this, just so long as you can have some way to get root on the system, either remotely or with physical access. You can run this program and compromise it. Now, only use this program, by the way, on systems you have permission to. Period. I wrote this as a learning tool, not as a script kiddie rootkit to go run around with. So, what we're doing is I have an install function here. I'm making, as root first of all, I'm making root.ssh. We're going into root.ssh. With SSH keygen, I'm generating a public-private key pair. And then I'm going to put the contents of that public key into authorized keys. Alright? After I do all that, I'm tarring up, making an archive, keys.tar/root, with the contents of /root/.ssh, and then the id_rsa files. I'm putting that in keys.tar. After I do that, I'm going and grabbing whatever the WAN interface is configured for. In this case, this only applies to pfSense, but you could apply this to others. You could change this line and search for something else. What I'm doing is I'm going to put the contents, the output of this command, in the variable WAN. I'm grepping for the capital A 12. I'm grepping 12 lines past my match. So I'm looking for the XML tag WAN in the quotes there, in the file conf config.xml. After I find that, I'm taking the output of that grep command, using it as input into this next command. And then in that XML block, I'm looking for if for interface. And then from there, that's going to become input with the pipe command to the cut command. I'm looking from I'm using a delimiter in the cut command, and then I'm using the bracket for that output, and then I'm looking for field 2. So I want cut based off that delimiter to show me, because cut will split it into 2 fields, the input you give it. I want to see the second field. In this case, the second field is part of the interface name we want to put in this variable. So from there, then I'm going to go to the remaining text from this, look at the other bracket that's remaining, and then I'm going to cut out the first field of that. In this case, that's going to be whatever the driver name is for the operating system. So in this case, it's going to be EM1, but it doesn't really matter what it is, just that we're putting it in the WAN variable. After that, I'm putting a pass all rule in. I'm using echo to make some output to output my rule without having to use pf.conf. And And then pfctl is going to, with those switches anyway, is only going to reload the rules. It's going to enable itself. And F is for the file. The hyphen is for standard input instead of a file on the file system, like we normally do with at cpf.conf. It's going to put pass all in its rule set. That's all it's going to do, meaning it's going to pass all traffic. It's bypassing whatever would be set up by pfSense. Same thing down here with NAT. We're natting. We're going to use that variable, and then just any traffic, basically just to make LAN-to-WAN communication still work. And then same thing with only the capital N there. We're piping it into pfctl and then putting that in. So that'll be our only one filter rule, one NAT rule. All right. After this, we're going to copy. Oh, one thing before we move on to that, you can also make a backup of the current rules and then put it in a file and rearrange it the correct way and reinsert. You could add on pass all on there, or just pass in on port 22, something to that effect, and then reload all of that so you still have the normal rules, and that would make it a little bit quieter and a little bit blend in a little bit better. I'm not going to add this to this program because it's already enough of basically a rootkit, so I'm not going to add any more. I'm going to leave that as an exercise if you want to do that. It's on my GitHub, as I said. From there, though, we're backing up SSHD. I'm going to modify it and permit root logins, appending it to what's already there, by the way. We're going to restart SSHD. One restart because it may not be on the boot system, depending on if it's enabled or disabled. And then we're going to echo root.bashrc rehash. And then this is redirecting all of its output to dev null. 2 is for standard error, and we're redirecting standard output as well to make it silent. And then we're redirecting that into etc.rc.local. So every time the operating system boots, it's going to run RC local last. So then this will run. We're going to make this executable. Then we're going to copy our script to /sbin to have a safe place to store it. You don't have to do this part, by the way, because forensically this is a big trace. Now we're going to make everything immutable that we're modifying, meaning the web application programs, like PHP in this case, cannot modify any of these files, so it gives us better persistence. It may break functions of the web interface. I don't believe it does in this case, but it does depend on what you're doing. If it needs to modify that file and you're making it impossible to do so, it could throw an error on the web application. But anyway, after we make all these immutable, we are catting our keys.tar we made earlier, and then we're piping it to netcat to listen on 8080. So this is actually going to be a blocking call. That means it's going to wait for netcat to complete before it moves on to the rest of the instructions. So at that point, we're going to have a shell open with netcat ready to catch the file, keys.tar, and put it into our own file locally, because those keys are going to allow us to authenticate as root to the SSH server we're starting. Okay? So after we do that, we're going to then remove our keys.tar, move our pwn.sh to root.bashrc, and then we're going to make that executable, make it immutable as well, and then it's going to live there as .bashrc, and then when it comes up, this reload function is going to be run, because we're doing part of that. We're getting our WAN interface, we're going to put our pass all rules in, and then restart SSH every time we boot. Now, again, you can make this blend in a lot more by getting your rules and rearranging them. Like I said, I'm not going to do that here. If you want to go that far, you can mess around with it if you want to. From there, for learning purposes, I also made a remove function that just takes off the immutable bits on all these files, copies the backup file back to the original SSH file, removes our hidden pwn.sh file, removes the .sh directory, local, etc., and then it's going to stop SSH. Now, that's just for the purposes of demonstration and learning. This is all that tool is for. If you use it for anything else, I'm not responsible. That's your own problem. Please don't. That's not why I made this. I made this to teach people how to secure their systems better and out of my own curiosity, because in this case I use a lot of pfSense, so that's why I have it attacking pfSense. So from there, our last thing is our options for our runtime options. I've put in option equals $, and then 1 in curly braces, meaning the first argument after the shell is called, after this script is called. And we're checking this variable. It can be I, it's going to call the install function. If it's R, it's going to call the remove function. And if it's rehash, it's going to call the reload function. So now you can see why I have this part as rehash. One, it blends in a little bit. If you don't know enough about bash RC, you're not going to know that isn't supposed to rehash. But it just blends in real good. And then when that's called every time on boot, it's going to run reload. And then the last option in my case statement just catches everything and tells you, hey, run it with those options. Then we end my case statement. Now, any good application that is this much of a hidden application for the most part needs a way to detect it, so I made a detect script that's also on my GitHub. And then from here it just looks at, puts cat root.bashrc, the first instance of finding install, puts in the detect variable, and then we're going to check that for install and then the function. It shouldn't be there, so if it's there, we're going to say, hey, it's there, remove this. Otherwise, it's not there, so the contents are normal. So that's all I'm going to do. You can expand that a lot more and get some variables for it and everything. But anyway, that is how this works.